PowerCad 5 integration with Revit2021 using the Revit app PowerCad-M. The PowerCad-M tab at the top here on the right, just click on it. It opens up the icon functions for PowerCad-M. Today we're looking at demonstrating the electrical distribution network browser that allows you to interconnect and connect the switchboards. So just click on the electrical distribution network browser, and the layout of this browser is that down the bottom is the unconnected switchboards plus the transformer. The open square in the center here is where we build the single eye diagram and do the connections. If you wish to have a look at the properties of any of the switchboards, just click on Properties and click on the Pacific switchboard, and you can then have a look at the various properties within that family. So just going back onto the unconnected area now. First, to build the single line diagram, we load the transformer. So just click on the transformer, move that into the single line diagram area, and now start to build the network. What we're trying to achieve today is a main switchboard with two separate buses. To do this, we need to build the switchboards and then convert them. So if we just add the first switchboard, drag it across until it connects with the transformer, then add the second board and move it across, and then add a third board and move that across and connect onto that board. Now we want to convert these two now into just two buses within the main board. So left click to focus on the board and then select edit the panel board. And you'll notice now that we've automatically selected the switch gear. Previously I'd set that to Siemens. This demonstration will include Siemens switch gear. So we just click up on the panel board and scroll down and set the split bus, and just go OK. And now that turns the first bus. The second, do the same for the second board. Right click and go edit panel board. There again we've got the Siemens switchgear allocated. Scroll down and go split bus. OK. So we've now turned the main board into a board with two separate buses. So now the next is to add each of the lower boards onto each of the buses. So just pick the first one, drag it up, connect it onto the first bus. Second board, just move it up onto the other bus, and then the last one just. So what we've done now, we've added two boards to each bus. Within the single line diagram here, we can now move boards around. So if we take this board here and just drag it across and add it to the second board. Each of the boards can be renamed. So we just click on the first one and go rename panel board. In this case, we call it for motor control center. And just go generate. Okay. And then the second board. Let's go edit the panel board. And we call this, just go rename. We call it SB and generate. Then the next one, rename, and we want to call this the motor control center. Okay, and the last one, and we'll just leave that as DB. So once we've built the single line diagram, we can then export that to PowerCad 5 for analysis. So we just do that before we add any of the loads and just have a look at the the interface between PowerCad-M and PowerCad-5. Up the top icon, we've got the export data to PowerCad-5. Just click on that. First, we just go export, and it'll do a quick check to make sure the data is correct and has continuity, and then it'll fire up PowerCad-5. So PowerCad-5 is open. We just go fit. This fit control is the same as the control in PowerCad-M, and you'll see now that the single line diagram mimics the diagram in Revit. So if we just have a look at, just double click on the transformer. It's got continuity of manufacturers throughout the network. We've got a Siemens transformer, and if you notice that it's got no load, just a minimum transformer, and each of the boards don't have any loads on at the moment. So if we just go back to, just to miniaturize that, we go back to Revit, and now we start adding loads to the board. So if we pick the first one, these are a pump family generated by BIM MEP Oz in Australia, and just connect that to the first board. So to motor control 1, pick the next one. You notice now that the board has the motor connected to it. We do the same for the next one, and we connect, and now it's got 2 motors. Do that with the next motor, electrical, and we give that to the second motor controls panel. So now we've got the load started to connect the loads to the board. So we just go export back to PowerCAD to have a look at the analysis. And we just bring up PowerCAD and bring the PowerCad-M in, and you notice now that the motors have been added to the various switchboards. So we just click on the circuit breaker, and you'll see now that it's selected the motor protection for that particular motor. Just have a look at the errors, and we'll see that we've got a discrimination error, a fault loop impedance error, and the let through energy for the earth for that particular cable at the moment is too high. We won't try and correct these errors at the moment until we've added more loads to the network. Just go back now to the single line diagram, and we can see that we can also start moving loads around. So if we pick on, so we can drag loads and reconnect them to a different board. So if we just go now to back to PowerCAD, so we export and bring up PowerCAD, bring the data back in again, and now we've got the model in PowerCAD for analysis. We can just double click on the switchboard, sorry, on the substation, and you notice now that it's starting to increase in size automatically as we add loads to it. So if we come down here, we can add, instead of being an infinite bus calculation for the fault level calculation, we can turn on the grid and add a HV relay, and now the calculation will be based on the medium voltage or HV voltage parameters. So we can also add loads here instead of adding them within the Revit. So if we just pick a board here, left click to focus, right click and go edit, and say we can add say 250 amps. Normally you would make sure you add the proper power factor, as PowerCAD, when it adds the loads through the network, treats these as vectors and adds them vectorially through the network. And also for the voltage drop calculation, that will be affected by the power factor of the load. So if we just come back now onto another board, go edit, and we can add some more load to this one, say 300 amps at 0.9. OK, and we come back up to the transformer, and you'll see now that it's now risen to a 630 kVA transformer, so it's automatically resizing the transformer as we go. So we start, any of the devices or in the network is turned red, there's a error that needs correcting. So if we just have a look at the first one down here and go errors, and the DLL criteria isn't met, so we can just go to motor starting and we turn this into a type 2 coordination, and automatically it reselects the overload relay and the line contactor. So come up to the second one and have a look at the errors, and we've got a discrimination error. So to correct that, bring up the coordination screen, and if we have a look at this, we've now got an overlay. So if we have a look at device 3 for a start, and we move the instantaneous back as far as we can, and then have a look at the device 2, and then we start moving the and then we have a look at device 3, sorry, device 1. We'll go back into device 1 and have a look at it itself, and bring up the service protection and have a look at the time current curve. Here we have a look at the arc fault and the earth fault. They're all good. They're all getting cleared in time in compliance with the standard. We can actually change the OCR and have a more. So if we go down and have a look at say 650, and then readjust the settings on. So we just move these across. So basically the settings are dynamically adjusted as we adjust them, and the discrimination is being checked automatically as well. If you want to have a look at the OCR in more detail, just bring up the OCR. In this case, it's electronic OCR. Let's close that. So we just work our way through. Let's go back to this breaker here and have a look what the problem is. We've got this discrimination problem. So there again, we come back, and it's the second one's got an overlap. Obviously, the adjustments we did weren't good enough. So we just come back with the settings and just move these around. Move the pickup, and we can drop this one back. So notice that on the time current curve, the box in red here gives you the clearance required to meet the standard. So if we just increase this now, and we find it automatically changes. Up the top here, we've now still got a clearance problem with the, which I'm not going to be able to fix that. So that obviously we'll have a look at the lower breaker, come back to the settings, and if we take it off automatic selection, we can then adjust the thermal in this particular breaker. So we just work your way through the network, adjusting the switchgear settings to clear either the fault loop impedance problem or the discrimination problem, etc. So the next is to have a look at, once we've gone through all these and corrected them, you can then export it to AutoCAD. So if we click on export, go to the options and make sure that it's turned off, not automatically close the drawings, because initially you need to check that the export is working correctly. So the first one you would just leave it on with the automatic closure turned off. PowerCAD 5 automatically fires up the AutoCAD, and in this case we're using AutoCAD 2021. It does the drawing, prepares the single line diagram, then normally if you had that as automatic close, it would close the drawing down. The option we're going to pick for this example, just come back up, is to export it as an X reference so that the drawing can be X referenced into your project drawing and then sorted out into different paper spaces. So you just click on the export. So yes, it fires up AutoCAD and is now preparing the single line diagram drawing. Right, now PowerCAD is exported the single line diagram to a AutoCAD drawing, and you'll see here now that we've got the representation of the single line diagram, and then we've got the summaries for each switchboard on the right hand side here. We can just zoom in and then just pan. We can have a look at the various information you can pipe into the drawing, the cable sizes, the size of the board, the breaker, the contact sizes, contact model numbers, and then that's now ready for exporting as an X reference into your project drawing. So if we just go back to PowerCAD now, what you can also add, if we have a look at, just scroll this down here, you can add a check meter. So if you click on check meter, drag it across and just click on it, and we just go and have a look at if we have edit the check meter. So it's put in a Siemens Centronic pack check meter. We can change the model. You can set different values to have a look at through the network. So if we just go back, and now we zoom into and you can see now that the check meter is displaying the current at that point. We can bring up edit the check meter again and have a look at the line-to-line voltage. Just close that, and that'll look at that through the network. So if we come down lower here, say just add another check meter down into here, and you'll see that it's looking at the line voltage. So if we come right up the top and add another check meter, and it looks at the line voltage closer, which is obviously getting closer to the 400 volts that it was set to for the distribution. Just go fit and have a look at the whole network. So just a matter of slowly adding the loads. Once the loads are completely added to the network, you can then go through and correct any of the errors that are occurring. So we just go back into Revit now and close it, and thank you for watching the demonstration of the Revit interface with PowerCAD 5 using the PowerCAD-M Revit app. Thank you.